Let's look at how we find derivative of products and quotients. So the product rule, meaning if I have two functions being multiplied and I want to find the derivative of each, which makes a new function, I have to do this by leaving the first term alone times the derivative of the second term plus the second term times the derivative of the first term. And so this is just other ways to write it. So leave the first term alone, derivative of the second. Leave the second term alone, derivative of the first term. And so that's all this is going to walk through. Leave the first term alone, take the derivative of the second, leave the second term alone, take the derivative of the first. Now as you notice, because multiplication and this being addition, the order doesn't matter. If you left the second one alone and then took the derivative of the first one, that wouldn't matter at all. So here I have two functions that are a product being multiplied, 2x squared times 3x to the fourth minus 2. So I leave the first term alone. I take the derivative of the second term, so that's 4 times 3, 12x to the third. The derivative of the constant, negative 2, just becomes 0. I then add the derivative of the first term, 2 times 2 is 4x, and then I leave the second term alone. So I left the first term alone, derivative of the second, left the second one alone, derivative of the first. And then from here I can multiply things out and collect like terms. From that last example, actually what you could do is you could distribute this 2x squared first. So I could take 2x squared times 3x to the fourth, that'd give me 6x to the sixth, 2x squared times negative 2, which would give me 4x squared, and now I can just simply use the power rule. 6 times 6, 36, subtract 1, 2 times 4, 8, subtract 1, and as you see, I get the same answer. And you might say, well, why wouldn't you always do that? Well, you're going to see later when we learn what's called a chain rule is sometimes this might be to a higher power and you don't want to multiply it all the way out. Remember what you're doing when you're finding derivatives is you're finding slopes. So if I had this example, find the equation of the line tangent to the graph of f of x equals 2x minus 9, x squared times x squared plus 6. This is a product. I want to find the equation of the line tangent, so it only touches in one place at x equals 3. So I need to find the slope, which is by finding the derivative, which says leave the first term alone, the derivative of the second term, derivative of the first term, leave the second term alone. And then I can plug in, I can multiply all this out, but it doesn't matter either way. I could plug in 3 because I want to know what the slope, the derivative is. Remember the derivative is the slope at x equals 3. So I plug in 3, I go through all this, and I get 12, which is the slope. So now that I have the slope, I need a point. Well, I have x equals 3. I could plug in 3 to my original equation and get my y value. So I know I have the point on the curve. This is actually my point that I'm trying to get the equation of the tangent line. I have a slope. I have a point. I know what you're thinking, right? Y minus y1 equals m times x minus x1. Good thinking, because I have a slope and I have a point. So I'd use point slope form. I plug everything in, I kind of move things around a little bit and solve for y, and that is my equation of my tangent line. So remember, you ought to graph these things, one, to see if you got it right, because you'd be able to see it. So what I'm graphing is my original function, and then I'm going to even plot my point 3, negative 45, my xy. And when I plot this tangent line, it better go through only at that point, and it does. So here's the red is my original function. I plotted my point, and then I also graphed my tangent line, which shows me it only goes through at that one point. Well, what if we had a quotient where we're dividing one function over another? Then we have what's called a quotient rule. A quotient rule says leave the bottom alone, take the derivative of the top, minus leave the top alone times the derivative of the bottom, and then square the bottom. So again, leave the bottom alone, derivative of top, minus leave the top alone, derivative of the bottom, and then square the bottom. So here we have a quotient. Leave the bottom alone times the derivative of the top, minus leave the top alone times the derivative of the bottom. And in this case, the order's going to matter in our numerator because we're subtracting, so you can't flip this order around. And then, of course, I will square the bottom. So let's do it. Leave the bottom alone times the derivative of the top, x squared, the derivative's 2x, minus leave the top alone times the derivative of the bottom, which would be 2, and then square the bottom. Okay, so again, leave the bottom alone, derivative of top, minus leave the top alone, derivative of the bottom, and then square the bottom. And now I can multiply things out and see if I can make this look a little bit better. I can collect some like terms. And I could factor out a 2, but I'm going to see that there's nothing that's going to cancel. So it actually wouldn't do me any good to factor anything out. Let's see one of these quotient rules in action. The total sales S in thousands of games, so we're selling video games, T months after the game is introduced are given by this function. So total sales T months after the game is introduced. Find the derivative. That's quotient rule, right? That's a quotient. So to find the derivative, I'm going to leave the bottom alone times the derivative of the top. 2 times 125, 250. Subtract 1, so T. Minus leave the top alone times the derivative of the bottom, 2T. And now I just simply multiply everything out. I can see the 250t cubes are going to so nicely cancel, and I get my derivative. Find S of 10 and S prime of 10. Remember, S of 10 is just plugging 10 in your original equation. That's like what you learned in algebra, right? But I need to interpret what it means. So I plug in 10 to this equation, which it told me this is total sales after T months, so after 10 months, and this is in thousands of games. So total sales after 10 months are 62,500 games. Well, now let's find, we found the derivative, but plug in 10. And so this is our quotient rule that we found the derivative. We plug in 10. And remember what the derivative is. This is a rate. Because this is positive, this says sales are increasing at the rate of 6,250 games per month. So remember, your derivative is a rate. And you could use this to estimate the total sales after 11 months, because I know the sales after 10 and I know the rate that it's changing. So I could simply take the sales after 10 months and add the rate for one more month to get 68,750 games.